Okay, so in this video I'm going to talk you through how I went about modelling my maze design for CNC manufacture. So you should have access to and be able to see the videos on setting up various milling operations in Fusion 360, which can then be translated over to the CNC router. So if you're a bit unsure about how to go about modelling your maze design, ready to develop your skills so that you know how to work and design for CNC production, this video should help you do that. So on the screen at the moment I've got an example piece of work here and just talk you through the basis of the design. So there are two key components, the base component, which is the part that's made on the CNC router, the acrylic top, which is the lid which keeps the ball bearing in there and allows you to see what's going on in the game, and then the four machine screws which would locate into threaded inserts, and I'll talk about those in a minute. So I'm just going to remove the four screws, select the main two bodies. We'll just talk a bit about the bottom one first. So we've got the overall profile cut from stock material. We've then got four holes here, and my idea was that just in terms of the assembly after manufacturing would be you'd have threaded inserts, which are essentially brass or steel inserts that have either got a serrated thread or a barb that taps into a hole. It could be into a polymer or into a manufactured board or timber. And then in the centre of that is a precision machined tapped hole to specific sizes. And you can get these in loads of different sizes actually. But for my design, I designed it to have the 8mm threaded insert, which has got a central M4 tapped hole. Okay, so those would simply tap into the hole. Because this is I've designed this to be out of timber, I probably wouldn't. The ones that have got the thread on can actually cause the material to expand, so you might get some splitting on the corner. Whereas the ones with the barb locate quite nicely, so I'd probably use ones with a barb just to tap in. Because there's not really, once it's screwed down, there's not really any tensile load pulling the top off this and the base piece. So, and then the last component, and the last component is just the secondary component. Sorry, is just the acrylic lid with the four holes. So I'll talk you through now how I actually went about modelling that, so that you can have a go at doing the same. So. First thing to think about is the material, and this is where design for manufacture comes in. Anyone can come up with creative ideas to varying degrees of success, but understanding how you design for manufacture is a really important skill. So for my maze design, I've thought about your class size and how many we've got to cut, and the bed of the CNC router. So we can cut 590 by 325. Okay, so that's the maximum envelope to work within. But you've got to think about things like tool passes between components. So if everyone designs a part and we put it all into the same file to manufacture them all in one go to save machining time, you've got to factor in the width of the tool and when it's cutting a contour out to cut out the various components. And then also things like clamping and fixtures on the actual machine bed are going to take up some of that measurement. So a 140 by 140 square gives us plenty of room, but also helps to maximise material usage, reduce wastage, and increase manufacturing efficiency. So first thing I'm going to start off with is, I've jumped ahead a bit there, I created that sketch on the ground plane just because that orientation works well for when we want to see our finished model. Extrude that 18mm standard manufactured board depth, and then we've got our basis of our maze on the screen now, the area it's going to take up. So I'm going to start adding features and I'll talk you through this. So the first thing I'm going to do is create a sketch on the top surface so that I can put those four points in for locating the threaded inserts. And as with anything in CAD, there are multiple ways of doing things and in different orders. So what I'm saying isn't the only way to do it, it's just the way I've gone about doing it. So first thing I'm going to do is use that project tool. So press P as a shortcut, and click on the face, click OK. So what that's now done is translated geometry from that face into my sketch, and that's represented by those pink lines. What I'm then going to do is press O for offset, and I'm going to drag my line in, and I'm going to go minus 10, and what that's going to do is copy the exterior profile 10mm in. Quite a useful tool, because what I'm doing here is saving design time. So if I finish the sketch and then click on the hole tool on the ribbon, I can then use that offset square to use the 4 points to set the location for my hole for the threaded inserts. So if I set the diameter at 8mm, we don't want a tapered hole like you'd find with a normal drill bit. The flat end mills leave a flat on the CNC router, leave a flat bottomed hole. So we'll set those to flat, and we just want a depth of 10mm. So now that's set, we can then start looking at how we actually transfer the maze design into the centre of the body of stock material. So click on the top surface again. We're going for a separate sketch. So I like to keep everything in my timeline at the bottom as separate features. Just means when I want to go back and edit something or check something, I know exactly where it is, and they're all separate parts. Rather than having to refer back to a sketch, things can get messy if you add lots of features from the same sketch. So I'm going to do the same thing again, just project the top surface, and then offset. I will use that main offset, and I'm just going to do that minus 14 might not be enough, 15 looks about right. All I'm looking at there is the distance between the edge of the side of this cutout here and that corner there, because this first section, this will get extruded down. So on this, it's going to get quite complicated, and you've seen before, always bring your dimensions off the drawing so they're clear for future editing. So I've got 15mm set there. I'm just going to work through this now, and this is where the first thing relating to our design is important, because the cutter we're using for this project, we've got lots of different diameters and lengths of cutters, but you want to find a happy medium with what you're using. So if we use a 5mm diameter cutter, then if we make the gaps between in our maze design 6mm, it will mean as it's cutting, it can clear the 2D pockets by cutting on both faces, so you get a nice clear and well machined finish, okay, as opposed to it just ploughing through in a single pass through a trench. So if you wanted an 8mm gap, you can use an 8mm cutter. You could do that, but we want it to actually mill it out and give us a nice finish. So what I'm going to do, if we're using a 5mm cutter, is I'm going to offset it by 6mm each time. And what you will notice is you can't, we're not offsetting an offset, we're just referencing each one to the original sketch. So I'm just going to work through and add each of these in. And this might seem really time consuming, but once you've done this, essentially the model is complete, and you'll see that in a minute. So each time I'm just deducting material 6mm further in. So in terms of my dimensions, we're adding 6mm on to the number. Okay. So we've taken So the values here increase 6mm at a time, but that corresponds to the drawing of reducing it from the offset by the original profile by 6mm in all directions. Okay. So what we then do is finish the sketch, go to a home view, press E for extrude. I mean, you can select the tools up in the ribbon. Using shortcut keys is a good habit to get into, so it'll improve your workflow. And you'll notice the number I added in there was so that we end up with an equal spacing. And then I'm just going to minus 6mm there, cut down and chop material out to a 6mm depth. So all we need to do then is add our maze feature in. So again, bringing in a new profile, create a sketch, and the bits, we just need to cut some entry points out. So I'm going to select project, and I'm going to project the top surface of each of those raised features there. I'm going to select the rectangle tool, and I'm going to draw in, avoiding the center point mark, because we don't want that. I'm going to dimension that to 6mm to match this dimension. Now you could do that on each one, but in case I alter my design in the future, what I'm going to do is use the equal constraint and just select that line, and I'm going to set that. In fact, you can just reference them through like that and it worked just as well. Okay, so I've set that to 6mm. So using the constraints is really important. Get practice in using those wherever possible, and think how could you use those, because once you get used to using them, it will improve your workflow. Now you can see on here these two lines on each of these are blue, and that's because in a 2D sketch you need two sets of constraints. Now obviously this square here is, these two lines are constrained by this geometry, but in the this plane, the horizontal plane visible at the moment, so the X plane, we're not able to, it's not constrained. So if I add a dimension here, we can then see that it's changed those lines to black, and that means they're fully constrained. It's a good habit to get into fully constraining your models, because it means that if you've got large assemblies or complex components and you move something or go into a sketch, it means a feature's not going to get thrown out without you actually realising that. Okay, I'm not going to spend the time doing each of those because this will work fine doing this. So what we then do is just select those sections, and again remove those with a cut, and we can see our puzzle coming together. And the next thing I'm going to do is think about how that's actually, and this is where your design for manufacture skill comes in again. So the cutters on a CNC router are of circular profile, so they won't cut an exact internal 90-degree angle, so you have to factor in the diameter of the tool within your design. So using the fillet tool, in fact let me close that, if I get my design nice and clear on the left, pop the fillet tool open, and I would add several operations here just to make sure this is really clear. So the first thing I would do is work systematically around and do the internal. Notice how I just pause to check I've got the right line selected. Do all the internal angles first, and just double check. See, I missed one there. Double check you're hitting and the correct points. Okay. Now the cutter, if we go 5mm, the smallest that radius can be is 2.5mm. Okay. So I'll just type 2.5, and all I'm looking at here are things like here, just to check that radius hasn't protruded out to that edge. So that looks fine to me. One thing that's worth noting about the fillet tool, once you complete the operation, and then if you go to the timeline at the bottom, So I'll just show you this now. Edit feature. You can't then deselect and change that selection set. Okay, so it's worth noting just to take your time to get that completed accurately. So I'm going to do a secondary operation here, and I'm going to do the external corners. And the reason for this is actually a functional aspect to the design. If you've got a ball rolling around in there, it's going to track better if there's a smooth profile for it to follow. Just take your time to check you're selecting the correct edges. I'm just going to double check I've selected everything correctly there. It looks okay. I've got one missing here and one missing there. So, I mean, you can obviously go back in after. I've set that to 2. So like on 1, 2.5. I'm just looking at these features here, how much they're changing. I think I'm going to stick with 2. Click OK. So that's now my component modelled on there, and then the next thing I'm going to do is add the top onto it. So what I'll do is create a sketch onto the top face, and this time we want to project the in fact we could just project this sketch, that'll save time. So if I project that, because we need these center points of the holes translated through to the top as well. So if I finish the sketch and extrude that, but this time in fact you could actually hide that first body, so it will enable you to select the center, and we'll extrude that 3mm. Click OK. You can bring that back if you want to, but for now we're just going to work on this top to start with. One thing that might have saved time there, actually, I had intended to put an external radius on, but we can add that later. So next thing to do, create a sketch on the top face of that, and this time we want to view that previously projected sketch that's at the bottom, and we're just going to use the project tool again, and I'm going to project the center point. So I'm not selecting the circle, I'm selecting the center point of each of those holes from the previous body that was the base of the part, and then I'm going to select the hole tool, click on those points, and this time we just want a 4mm hole because the laser cut is very precise, and we can go, because this is all being machined within a very fine tolerance, we can set this to go pretty accurate. So we go 3mm depth that matches the material, and then that's basically the model constructed. The last thing I'm going to do, as I mentioned, is just add that fillet onto the components. So carefully selecting those edges. If we go 8mm, that will match the hole on the bottom. Okay, so to make this a bit clearer about what's going on with the design now, we can go into the render tab, and we can start adding some material. So I've just downloaded a semi-gloss maple appearance. Drag that on. Change the scene setting a little bit, just get a clearer view. Turn the brightness up a bit. Change the focal length. Okay, and you get a better representation of what that's going to look like. So back into the design tab, and just to finish that off, one technique that's quite useful is actually adding the mechanical fixings. Makes the designs look more professional, well presented. So go to Insert, And all types of CAD software have these. Sometimes they're manufacturer or developer specific, but sometimes they're a third-party install. So if you go insert McMaster-Carr component, and this is another thing that links to your design work, thinking about what fixings are appropriate. If you've got quite a small screw head and you apply quite a lot of torque to it, and you get a point load on something like acrylic, you can get cracking. So if we go to screws and bolts, then this is where selecting the right type of fixing comes in. So you go round head screws, and then a flange round head screw just has a larger surface area to distribute that force more evenly. And something like this, you shouldn't be over tightening it anyway. Set the system of measurement to metric before you go in, and it will just reduce the number of parameters that you've got to sift through. So could have some black finish ones. Just get stainless steel, and we want M4. Okay, and you've got to think about the depth of your fixing. So if the material you're fixing is 3mm, with a nail, you really want to, or something like that, or wood screw, you want to go 2/3 the thickness of the material if you want a good structural fixing. Machine screw, depending on the application, if there's not a lot of tensile load or bending and compression, you could go the same thickness, but it's not a lot of purchase, so I'd suggest going at least around 9mm. So we'll go for a 10mm machine screw. And now to get this into the model, just click Product Detail, and then you want to select a 3D step file and click Download. And then what that'll do, it will insert the model of the screw into your design, and you're going to have to use this coordinate system to move the model around. You want to change the orientation so it's correct on the screen, and then click OK. Once you've got one in, there's no need to go back into McMaster-Carr. You just select the joint tool at the top, capture the position, don't click continue, because it will put the screw back where it was set. And this time, just don't, because obviously when a screw thread is cut, you don't want to pick up the pitch or the profile into your selection. So you want the exterior of that top flange. And then once you've done that, zoom in, and you just want to select the top face of the acrylic with the center point of the hole, and it will drop the screw in. And what you can then do is zoom out a little bit, right click on that component, copy it, right click in the workspace, paste, not copy, and you've got your secondary fixing, and just repeat that process again. So it's just a nice finishing touch for anything you go about designing. And if you want to remove the joints from the view, just click on the visibility tab there. Okay, and then don't forget, anything you do appears in this timeline at the bottom, so you can actually roll features back. Okay, the timeline is so useful. If you, for example, if you model something where you've got one component added to another component, and then you decide to mirror the component on the left, but when you finish the whole model, you decide to add a feature like a fillet or something to a specific part. Instead of adding it twice, you can add it once to the first part and then just drag the feature back in the timeline so that it happens prior to the mirroring operation, and it will update the part. So don't forget the usefulness of that timeline. Okay, so hopefully that's useful for you. Just to recap some of the key points. We've got two bodies there constructed. You want to set out your design on paper first, get sketches and thought process down before you start modelling. Remember the spacing is dependent upon the cutter, and then once you've done that, you can move into a machining operation and setup, which is covered in a separate video. Okay.